Primary haloalkane goes through SN2. The first thing I want to do right now is talk about the 2 in SN2. Where does it come from? A halogenalkane such as bromopropane is primary because the carbon that is attached to bromine still has 2 other hydrogen. The nucleophile, in this case hydroxide, comes from either potassium hydroxide, a dilute solution of that, or sodium hydroxide, a dilute solution of that. And you will produce a propanol, which is primary alcohol, and bromide ion is going to get released, and eventually you have potassium bromide. If you recall from last year, in order to find out the rate of this reaction or how the concentration of these 2 species might affect the rate, we would do experiments. That in one experiment, for example, we would hold concentration of, if you look at 1 versus 2 concentration of hydroxide constant, we would double the concentration of the other one and see what's the effect on the rate. And you see, as you double it, the rate doubles. So this is indication that the rate is equal to a constant K times halogen alkane to power 1, first order. Now if we inspect the experiment number 1 and experiment number 3, you see as halogen alkane is held constant, the hydroxide is doubled and the rate doubles. This also says hydroxide is first order in that rate expression. So bimolecular, the 2 comes from this fact, that in the rate determining step, there are 2 molecules are involved. Okay, now that the 2 is understandable, we have to talk about the mechanism, how this reaction takes place, and as a kinetic chemist, we have to come up with this. Now, bromopropane, to reveal it, I'm going to give you the tetrahedral version of it. The solid wedge is indication that this C2H5 is coming to us. The dash wedge is saying hydrogen is going inside. The first thing you should realize is when bromine is going to leave this and hydroxide takes its place, this is known as inversion. There will be an inversion of the tetrahedral. The leaving group, which is bromine, has no choice but live in this fashion, in this direction, and then the hydroxide or any other nucleophile is going to attack it from the back. So the lone pair. And these are curly arrows that you have to remember. So the direction of the electron is from the tail of the arrow to the head of the arrow. So this is how you attack the carbon, the positive carbon. And bromine is going to leave in the other direction. So it will be a flipped version, and final alcohol will be in this fashion, that hydroxide is in the back now. And also you have your leaving group, bromide, so I'm going to write it. Now the question is, how can I show steps involved in order to get this bimolecular notion out? There should be only one step, that both species are shown. And that step is shown as a bracket, which is an activated complex. So the charge of the hydroxide is shown on the active complex. Then you're going to draw your tetrahedral, the hydrogen, the C2H5 down here. Now what happens, there is a dashed line that bromine is trying to leave. The pair of electrons is going to travel with bromine, so a curly arrow, and then hydroxide is going to take its place from the back. So this is what happened in the attack. And this activated complex is highly energetic. It has high activation energy. There is only one step involved. Both species are shown, the nucleophile and the halogen alkane, and finally you have your final products. So pay special attention to the process of inversion. So from here to here for SN2, there is inversion of the molecule, because the leaving group has no choice but has to live from one direction, and the nucleophile has to attack it from the other direction, which is the back side.